Welcome to a new test and teardown video. I'm still playing with homemade equipment, and this is, as you can see, another one of the really beautiful and well-made homebrew projects. It is just fantastic. Just by looking at it, I'm kind of trying to figure out what this means. VK, IK. So what is the K? Is it me who's completely stupid? So I guess this is the current. Or so this is like maybe fine. Of course, adjustments of volts, I guess. Oh, I don't know. And here we can switch something on and off. Maybe just the output we can turn on and off. And this is probably overload. And I guess the amp meter can be 0.1 or 1 amp full range. And that will be mains. So it's that simple, really. But it looks really nice. I'm super happy about it. I can't wait to see what is in there. And oh yeah, look at that. We got a big, powerful BD130 transistor from Siemens on a nice heatsink. And look, it's made with pigtails and yeah, everything here is just made right. Super right. I like it. So let's power it up and see if it works. We are ready to power up, and here we go with mains. Why is that? Oops. Negative voltage output. That can't be good. Oh, okay. How. So what is that? So it disconnects. Whoa. Hello. That only worked once. Okay, so here's volts. What is this? Okay, so this is the fine tuning. Okay, so far let's crank it all up. Okay, 31. So that will be volts, okay. And this is probably the current setting. But what exactly is this doing? Ooh. So there's a discharge resistor. And there's a loose connection in the... So now it almost works. Oh, okay, here we go. So when it is in, I don't know what that is. Then it goes to, okay, it goes negative. That is some kind of a funny thing. I think we need to look inside. Let's see if the meter is accurate. If this is 10 volts. Okay, that's actually pretty good. But this, I don't know. I think there's a discharge resistor that was put after the amp meter. Of course you want to put all this in front of the amp meter, right? Because you don't want this to happen. Ooh. See? Yeah, there's a... Let's look inside. See, this is very beautiful. Got a little bit of components mounted up here, but they're Everything is mounted using pigtail technique. I kind of like that because this gives very, very good and stable solderings. Also see here on the top of the two resistors here in the middle of the picture. This is definitely how you do high quality solderings that will just last forever. And this is the same done on the transistors. So this is the driver for the output transistor. And try and look at the circuit board. It's one layer. I bet this is hand drawn or litra set or something like that. I am definitely going to have a look at that. But where's the op amp? It's made of only transistors, and a lot of them. So how old is this design? Well, into perm and then this number, and we got some capacitors here, and sometimes this is actually a date code 70, but it can't be 70. And then what, 96? I don't know. That capacitor looks a little bit dodgy when it comes to the coloring. Is this acid leak? There is no acid leak on the PCB around this capacitor, but definitely it looks a little bit funny. So how about the transistors? Can we? I don't think so. We can't really date this thing by looking at the transistors like that. It's just BC what? 237 and the 308 is that one, and a lot more 308s, and yeah, 237, that's it. I don't think there's a really good way to date this other than just guessing. But it's already like 20 or 30 years old, definitely. But exactly how old how old could this be? It could have been all the way back to the 80s or 90s. Something about that. I give you a high score for using transistors only. I mean, that is definitely some challenge accepted. I would say. Oh man, that is pretty good job, and all the wirings that's made really beautiful. Maybe we could lift up the PCB a little bit and have a look under that one. I would love to see how the design or how the layout was made. And of course, this is absolutely funny. So this is a kid or some, because why would he? This is a Danish guy, by the way, who made this power supply some 40 years ago, right? And this is written in German. So he found this PCB or the drawings for the PCB in some magazine or something, or bought the PCB as a kit. Wow. But there is no other name, there's no brand name, there's nothing. So that means there's no way I can look this up, except if there's anybody watching this video who can tell me where is this design from, the name or the age or whatever. But you can see there's a lot of modifications. And by the way, this is called mini mount, and that was also very, very popular back in the 80s and in the 90s. And he's been using mini mount in many other products and projects of his own. So mini mount is definitely a thing. I would also expect to find some sort of a name label on this cabinet, but it is not here. I think somebody told me this case could be called Teco, I'm not able to verify the brand name of the case, so that is also a problem. This is powder coated aluminium. Even the top is a little bit bended here. I'm going to fix this, and then I'm going to mount the PCB again, and then I'm going to measure some ripple and load regulation experiments, because of course it's going to be interesting to see how this performs. So we're testing this thing at 500 milliamps. Then we see a little bit of ripple. I am in 20 millivolts per division, so this is less than 10. Oh, it actually says here RMS, only 3 millivolts of RMS, and this is the peak value. That is not a lot, and at 500, yeah, look at that. 500 milliamp load, definitely. Well, look at the meter here, it needs a little bit of adjustment. I think this is one of those resistors here. Oops, we need some light. Some other resistors here for the different amp settings, but I think this is a little bit confusing about this setting, because this is not the amp meter. Look. Oh, now it is. Okay, it's because... Okay, we got some... Aha, that is the problem. I got... This switch needs a little bit of service. And, okay, so let's take the current. Let's crank it from 500 down to not 100. Let's do 50. So this is 50 milliamps. Yep. Oi, that is super accurate. So 50 milliamps is super. All right. 50. Okay, let's do 60, 70, 80, 90, 100. Haha. Super accurate. You can see it. I'm jumping in 10 milliamps steps. Okay, so that is what it is. And then we go back here to 50. So it's the 1 amp setting is really not that good. Let's go back to 100. Yep, and then it goes 200. Ooh. Okay, let's go back to 500. 600, 700, 900, 1 amp. And of course it's just hammering out here because it's reading a little bit too much. And here we go. 4 millivolt RMS. That is not bad at all for its age. And also remember, there is no op amp, only transistors, and the gain they provide, and probably this capacitor isn't really that good anymore. I could probably just go and sneak in here and do a little bit of measurements on the capacitors if I wanted to. And then I think it's a little bit funny with the, see? Now I'm in voltage mode and current mode. So this is what it is, but this is a little bit weird. So now it's disconnected. And then it's on again. And then I need to do something here to turn this on and off. I don't understand exactly this. I think this has something to do with a foldback mode, see? Ah, that is exactly what it is. You wanted it to be in voltage or current mode, see? In and out of voltage and current mode. That is what it is, this setting. And if I go to disconnect, this means disconnect. Then if I go to, see, constant current mode, then instead of going back into constant current mode, it just folds back, and that is in amp overload mode. So now it's in fold back mode. See? Haha! That is what it is. It goes to total kill. Now I figured this out. And then we can go back on into constant current mode. Alright, so it's got a fold back or a constant current mode. I haven't seen that before, by the way, on old stuff like this. So that's quite impressive. I just measured the idle voltages on the two capacitors. So, and this power supply can give you 30 volts of output and 1 amp, but it can also give you 1 volt output at 1 amp. So now you can imagine something is going to get hot really, really fast if we do that. And now I'm going to try and do that. This is probably the meanest you can do to a linear power supply. 1 volt output, 1 amp load. Look at that. Here's your 1 watt to your output. But here's your 50 watts of mains input. And where is the 48 or 49 watts? And it's only a few seconds ago. Okay, we need to turn this off, because of course I'm not going to blow this up. This was just to illustrate exactly what's happening and why all modern linear power supplies like this one, they probably have a relay or 2 relays to select different secondary tapping. So that voltage could be much lower depending on this output voltage setting. So otherwise you can imagine this heat sink should have been this big, and it's just a lot of wasted power. And when there's no load on the output, the idle power is only 5 watts. So that is perfect. You can leave this on the whole day and just be happy. Fantastic. Oh, by the way, let's just measure the ripple on the main storage capacitor. I'm in AC mode and I dialed this up to 1 volt per division. Okay, let's just see. This is the idle. So this is the idle. Why? Wow. Look at that. 180 millivolt peak ripple on the capacitor in idle. But let's try and give it 1 amp load. Like that. 3 volts peak. And the capacitor is supposed to be 2200. And obviously we also got some serious resistance, and probably not exactly that value. You can easily do the math and see if this is right or wrong. I think this is definitely where you want to fix this. Also, it could be an interesting idea to measure the other one and see if that capacitor got some ripple. And what do you know? The other one is only for biasing all the voltage regulators and the voltage offsets and stuff. And here is how it looks. Really, really nice sine wave of 110 millivolts peak on that one. And this is because they're using series resistors and the bridge. So this is a very good idea to charge the capacitor in a really nice and smooth way, so you don't have any high peak currents in the voltage reference system. So that is fantastic. And this is of course why the ripple looks like this.